we are kicking things off with the cosmos. NASA's Juno mission has delivered mind-blowing revelations about Jupiter. The Juno team members at the European Geosciences Union's 2026 General Assembly in Vienna just announced that the interior structure of Jupiter is far more complex than anyone previously imagined. They are sharing incredible data from the spacecraft's 83 orbits, detailing how Jupiter is modeled like an onion with many layers, and hinting at a solid core made of heavy elements that completely flips conventional planet formation theory on its head. This changes everything we thought we knew about giant planets.
Here's a simple way to protect your phone without stress. This ALEN 3-pack comes with tempered glass screen protectors, camera lens protectors, and an installation frame for an easier, cleaner fit. It's clear, case-friendly, and built to help guard against scratches and everyday bumps. Check the link in the comments to get it on Amazon.
Next up, we shift focus from the outer solar system to our journey to the moon. NASA's Artemis 2 mission has just dropped over 12,000 stunning photographs from the lunar surface and beyond. Planetary scientist Margarita Bassi shares the awe-inspiring views captured by astronauts Reed Weissman, Victor Glover, Christina Koch, and Jeremy Hansen as they got close to the moon, including incredible shots of Earth eclipsing the sun from the lunar perspective and capturing ancient impact craters like Integrity and Carroll. These images are now being uploaded to the Gateway to Astronaut Photography of Earth for everyone to see. Now let's talk about pushing the boundaries of speed in space technology. NASA is accelerating the testing of its experimental supersonic aircraft, the X-59. The agency has increased the flight test pace to 2 flights per day as engineers work to expand the aircraft's flight envelope up to Mach 0.95. This increased tempo is crucial for gathering data during the envelope expansion and acoustic validation phases of the Quest program, all aimed at developing technology that could reduce noise pollution from future supersonic flights over populated areas. And finally, we look right here at the International Space Station, where the work never stops. As the SpaceX CRS-34 cargo mission approaches launch, the station is buzzing with advanced research. Flight engineers like Jack Hathaway and Sophie Adenauer are busy installing new life support hardware, updating the water recycling system, and conducting critical physics investigations inside the microgravity science glove box. Join us for the latest updates on the ISS, and don't forget to subscribe to Channel YouTube for your weekly dose of space news. NASA's Juno mission to Jupiter has unveiled an interior structure far more complex than previously imagined, according to several members of the scientific team speaking at the European Geosciences Union's 2026 General Assembly in Vienna. On its 83rd orbit, the solar-powered spacecraft reported excellent health. Launched in 2011, Juno's primary objectives were to illuminate Jupiter's formation and evolution by measuring its interior, atmosphere, polar magnetosphere, magnetic field, and gravity field. The mission has made significant strides, currently navigating toward Jupiter's North Pole, a region previously inaccessible due to intense radiation belts. Due to Jupiter's non-spherical shape, the spacecraft's closest approach is now near the pole rather than the equator, allowing it to scan the planet nearly pole-to-pole on every orbit. The data gathered over these 83 orbits necessitates modeling Jupiter like an onion with numerous layers. Theorists have long viewed Jupiter as a swirling storm, but recent research suggests a deeper complexity. Given Jupiter's composition of hydrogen and helium, theorists are exploring scenarios where it might resemble a failed brown dwarf star if it were significantly larger. The mission has directly challenged conventional planet formation theory. While standard accretion models suggest Jupiter would accumulate hydrogen gas, leading to liquid, and then metallic hydrogen deep within, Juno's findings complicate this picture. The team cannot confirm the existence of a compact core smaller than 6 Earth masses. Instead, they suggest either no solid core exists, or that any core present is composed of heavy elements beyond hydrogen and helium. Using its microwave radiometer, Juno has revealed that Jupiter's atmosphere is not well mixed, and at depths of 7,000 kilometers, molecular hydrogen and helium become so dense and ionized they transition into a metallic state. Juno has already surpassed its nominal mission goal of 32 orbits, and the spacecraft remains healthy, continuing to deliver crucial data. While principal investigator Scott Bolton noted the existence of a large, diffuse, dilute core and the use of machine learning to interpret results, modeling a Jupiter that matches current observations remains a significant challenge. Planetary theorists continue to debate whether a gas giant like Jupiter is necessary for the orderly formation of the inner solar system. The Juno mission is poised to fundamentally reshape our understanding of the solar system's largest planet, emphasizing that the details of planetary science are often far more intricate than simple models suggest. NASA is rapidly accelerating flight testing of its experimental X-59 supersonic aircraft as preparations for future trials intensify. The agency has increased the test pace, with the aircraft now conducting 2 test flights per day to expedite data collection during the crucial envelope expansion and acoustic validation phases of the Quest program, which is slated to continue through 2026. The increased tempo was highlighted after the X-59 successfully completed its first dual-flight test day on April 30 at Edwards Air Force Base, California, executing its 11th and 12th flights. During these missions, the aircraft operated at altitudes ranging from 12,000 to 43,000 feet, achieving speeds between Mach 0.8 and Mach 0.95, as engineers push the aircraft's operational limits. The X-59 is central to NASA's efforts to demonstrate technologies designed to mitigate noise pollution from supersonic flight over land. Rather than generating a traditional sonic boom, NASA anticipates the aircraft will produce a softer thump, a critical factor for supporting potential future regulatory changes that may ban civilian supersonic flights over populated regions. Designed by Lockheed Martin under the Quest mission, the X-59 incorporates a long, narrow fuselage, canards, and an engine positioned on the upper rear fuselage to minimize shockwave interaction. In the coming years, the aircraft is scheduled to conduct flights over selected U.S. communities to gather essential public response data, which will inform regulators as they review future supersonic flight rules. Noi Dung Kai Tight. NASA has released over 12,000 stunning photographs from its recent Artemis 2 mission, providing unprecedented views of the lunar surface, Earth, and a unique solar eclipse event. The mission, which sent 4 astronauts, Reed Weissman, Victor Glover, Christina Koch, and Jeremy Hansen, close to the moon, generated a wealth of visual data. While some images were shared during the mission, the majority were delivered via physical SD cards upon the crew's return. /N/N, the extensive collection includes shots of the 30 designated lunar surface targets, 2 ancient impact craters crucial for understanding lunar evolution, alongside breathtaking views of Earth and a solar eclipse observed from the spacecraft. Planetary scientist Kelsey Young described the images as awe-inspiring. /N/N NASA has uploaded these new images to the Gateway to Astronaut Photography of Earth database, with photo IDs ranging from ART002E168 to ART002E30001. The photographic data was captured using various equipment, including Nikon D5s, a Nikon Z9, GoPros, and even iPhones. /N among the highlights are images capturing the Hello World view of Earth, showing the planet's appearance relative to the moon, and striking views of star trails and the Milky Way galaxy. The mission also featured a remarkable solar eclipse, which the crew witnessed, an event invisible to observers on Earth, by seeing the sun disappear behind a different side of the moon. /N during the mission, the crew proposed names for 2 lunar craters: Integrity, named after the Orion spacecraft, and Carol, honoring Weissman's late wife. The International Astronomical Union will now determine the official status of these names. /N following the mission's successful conclusion on April 10, the lunar science team has 6 months to release the entire dataset, including all images and initial reports, which will ultimately be archived in NASA's Planetary Data System for global research access. /N/N, the next phase of the Artemis program is slated for 2027, focusing on testing the Orion spacecraft's ability to dock with commercial lunar landers and piloting new spacesuits. Station activity is heating up as the SpaceX CRS-34 cargo mission approaches its launch at 7:16 p.m. EDT today from Launch Complex 40 at Cape Canaveral Space Force Station. The uncrewed Dragon cargo spacecraft is set to deliver approximately 6,500 pounds of vital supplies, including science experiments, crew provisions, and lab hardware, to Expedition 74. Flight engineers Jack Hathaway of Channel YouTube and Sophie Adenauer of the European Space Agency will monitor the Dragon during its automated rendezvous and docking scheduled for 9:50 a.m. on Thursday, May 14. In preparation for the arrival, Hathaway and Adenauer will join Channel YouTube flight engineers Jessica Mayer and Chris Williams the day before to conduct a cargo readiness review and begin unpacking time-sensitive research samples from Dragon's portable science freezers shortly after arrival. Meanwhile, station crew members have been engaged in critical maintenance and research across various modules. Hathaway focused on installing new life support hardware within the Tranquility module, updating the orbital outpost's water recycling system to decrease reliance on Earth resupply. Adenauer managed agricultural studies by watering and photographing alfalfa plants in the VEG-06 space agriculture experiment, and reorganized the Quest Airlock and Harmony module to accommodate the incoming cargo. Jessica Mayer initiated her shift by swapping sample hardware inside the Destiny Laboratory module's microgravity science glove box for a physics investigation into how weightlessness affects particles in a colloidal solid. She also completed the installation of the Cold Atom Lab's new science module, a quantum physics facility delivered via the Cygnus XL cargo spacecraft. Chris Williams tested a robotic arms precision manipulation capabilities in the Kibo Laboratory module before performing scientific maintenance on a research freezer, centrifuge, and incubator components. Station Commander Sergei Kudzverchkov and Flight Engineer Sergei Mikheyev worked with Roscosmos crews on Tuesday, unpacking supplies from the Progress 95 cargo spacecraft and transferring water from the Progress 94 spacecraft. Kudzverchkov also began configuring the Poisk airlock for an upcoming spacewalk, while Mikheyev configured computer networking hardware supporting Earth observation equipment. Roscosmos flight engineer Andriy Fedyaev managed maintenance on the Zvezda service module, replacing hoses and valves related to water removed by the dehumidifiers, and concluded his shift by servicing smoke detectors in the RASFIT module.